Okay, so let's continue to do some more examples. This example 2. This is page 12. The integral of b1 to the power k dbt equals what? And k is a positive integer. The integral, instead of 0 to 1, this time I'm going to do the integral from 0 to t. Oh, then I should change this t to s. Sorry about it. The reason that I want to replace 1 by t for the upper limit integration is then this is a stochastic process. Okay, so again, b1 is decomposed into bt plus b1 minus bt. And then to the power k is just this to the power k. Therefore, the integral from 0 to t of b1 to the power k dbs is almost equals, namely by taking the limit, and I just omitted the notation limit. Summation I from 1 to n of. Here we have two terms. For the first term is from the iter part, namely it's adopted, so it's the evaluation. Oh, I'm sorry, I should change this to s. This s, s, and s. Okay. bs plus b1. Oh, here, I'm sorry. The evaluation at I minus 1. And then b1 minus b is I to the power k. And then the Brownian motion increment s sub I. And that equals to summation I from 1 to n. And then we use the binomial expansion for this to the power k. And we get b I'm sorry. First, we rewrite this sum as b1 minus the Brownian motion increment as before to the power k. And then we use binomial expansion. And we get b1 to the power k minus the second term is k times b1 to the power k minus 1. And the second term here, Brownian motion increment. And then plus the higher order terms. And then Brownian motion increment. And then as n goes to infinity, this goes to the first term and the Brownian motion increment, multiply them together, we cover this. Multiply them together and then sum this up. We get B1 to the power k and then the sum of the Brownian motion increment, this time is from 0 to t. And so the the sum is just b at t, bt. And then the second term minus k times b1 to the power k minus 1. And now look, this is the Brownian motion increment. Times the Brownian motion increment becomes the Brownian motion increment square. And by the causative variation is equals to the time increment, namely is this time this becomes delta S sub I. Delta S sub I, and so the sum is t on the interval 0 to t. And now for the higher order terms, the higher order term is all 0 because after this this term, the next one is Brownian motion increment square, and the square times this, that becomes the limit is 0, and so forth. And so this is the limit, and therefore we have the integral from 0 to t of b1 to the power k dbs equals to, and you see it looks like we bring b1 to the power k out and multiply by bt. But there's a correction term, namely minus k times b1 to the power k minus 1 times t. And this is for t between 0 and 1. By the way, here I should mention that t is between 0 and 1. And so we have this equality. And in particular, when k equals 1, we have the motivating examples. In particular, the integral from 0 to 1 of b1 dbs is b1 bt minus t. And by the way, this is for 0 between 0, t is between 0 and 1. Okay, we'll stop right here and then we'll continue in the next video.